So g prime of pi is going to be 2 times pi. Make sure, yep, okay. Cosine pi plus 2 sine pi. Okay, now the cosine of pi is 1 and the sine of pi is 0. So this is going to become 0, and this is going to be 2 pi times 1. And so our mt is just 2 pi. Now we're looking for mn, which is the normal to the curve. Remember that m sub n is negative 1 over m sub t. So this is going to be negative 1 over 2 pi. Okay, and let's grade it. So +1 method mark for solving for MT, +1 answer mark for getting the correct MT, and then +1 for actually solving for MN, which is what we were looking for. Okay, cool. And that's out of 7. Okay, the total on your page should be out of 13. And our last part for section A, or paper 1, I'm sorry, paper 1, section A. So for this one, part A, so it gives us 2 functions, f and g. First, it asks us to find each derivative. So for part 1 of A, f prime of x, so the derivative of e to the x is just e to the x, but this is 3x. And then we would have to multiply by the derivative of that inside piece. The derivative of 3x is just 3, so I put my 3 out front there. So 3e to the 3x is f prime. Now for part 2, g prime of x. So the derivative of sine x is cosine x. And we keep the inside the same. Okay, and then we would have to multiply by the derivative of the inside, but here the derivative of the inside is just 1 because the derivative of negative pi over 3 is 0 and the derivative of x is just 1. So this should be our final answer for g prime of x. I should probably get my old key all the way out instead of just rambling on freely. To make sure I'm actually telling you the correct thing. Okay, good, that's right. That whole part was 2 marks, and you just get 1 answer mark for each of those solutions. Okay, hopefully those were easy. For part B, it says let h of x be sine x minus pi over 3 over e to the 3x. Find the exact value of each prime of pi over 3. So basically, part A sets you up to be able to solve for part B. It gives you a quotient rule problem. Some of you may turn this into a product rule problem. If you solve it that way, fine. So h prime of x, we're going to have ho d high. Ho is 3e to the 3x. The derivative of the top we found in part 2 of A is cosine of x minus pi over 3. That was an ugly x, but whatever. So ho d high minus high sine x minus pi over 3. D ho, the derivative of the bottom, is just 3e to the 3x all over ho squared. Now, I'm going to write it this way, but that's really, when you have a power to a power, you multiply, so it's really e to the 6x is how you would write it as. But we don't have to necessarily simplify it all the way down. So because we're just trying to find h prime of pi over 3. Okay, it doesn't tell us to simplify. Why simplify when we could just leave it like that? And if we just sub in pi over 3 everywhere, this will be nice because it's just like cosine of 0 and sine of 0. So we're subtracting pi over 3, 3e, 3 pi over 3. There's so many 3's. And then all over, sorry, I went like off the page, e to the 3 times pi over 3 squared. Okay, and now e to the 3 times pi over 3 is just e to the pi times the cosine of 0. Cosine of 0 is going to be 1 minus the sine of 0. The sine of 0 is going to be 0, so this whole thing is just going to end up being 0 after this minus sign. And then on the bottom, 3 over 3 is 1, so this is just e to the pi squared, which is e to the 2 pi. Okay, and so now this whole thing becomes 0 because the sine of 0 is 0. The cosine of 0 is 1. So this ends up just being e to the pi over e to the 2 pi. Now, we could rewrite this so that, and this is a little extra work, but whatever. This is really e to the pi times e to the pi on the bottom. It's like e to the pi squared. And so I can cancel out one of the e to the pi's on top and one of the e to the pi's on the bottom. So I get 1 over e to the pi. Ew. You could also rewrite it as e to the negative pi. That would be a correct answer as well. But that is that. So for grading that piece, you get 2 points for taking the correct derivative. So this setup has to be correct, and it doesn't have to be simplified, but you have to take the correct derivative in terms of x. And then you get 1 method mark for subbing in pi over 3 everywhere. And then you get 1 mark for your final answer. I would accept, in addition to 1 over e to the pi, e to the negative pi, but not a decimal because that would mean you probably used your calculator because I don't know off the top of my head what 2.71 to the negative 3.14 is. So I don't believe you can. Yeah, so either of these would be fine, and this is your actual final answer, or that, either one. Okay, so that is paper 1, section A.